Hi everyone, welcome to week 7. This week we're talking about understanding the process and descriptive analysis and interpretation. So just full disclosure right from the get-go and to set expectations for the descriptive analysis portion of this lecture. If you've taken a statistics course or like a foundation of stats, probably a research course, this is going to be review. However, that's not a bad thing. It's always good to review concepts, make sure you understand the basics before you move on to something more complex. And with that, before we dive into content for this week, I do want to go over the midterm because I'm sure everyone's got some questions on it. So I'm just going to give some background on that. So the midterm, it will be done via the lockdown browser. So please make sure that you have that installed. If you are installing it for the first time for this midterm, I do suggest booting it up once after you've installed it just to make sure that it works. That way it's not kind of like you hope you installed it correctly as you go to do the midterm. With that, make sure that when you do go to complete the midterm, make sure you have a solid internet connection. I'm pretty sure that's a given. If you can, be wired in. That way there's no Wi-Fi issues. And put yourself in a quiet place where you can think. Additionally, so the content of the midterm, it's going to include all lecture weeks up until and including this week. The midterm is going to be 60 questions. You will have 90 minutes to complete the midterm. You can go back and forth between questions, so that's not a problem. However, you do only have one attempt at it. Okay, so once you hit submit and it goes in, that's it, game over. In terms of when you can do the midterm, the way this works is I will open the midterm on Monday, probably 8 a.m. Go with 8 a.m. unless I announce otherwise on Canvas. And you will have until Sunday at midnight of next week. You can do it any time in that period, but like I said, you can only do it one time. Now, as I can't be on Canvas for that entire time period, if you run into an issue, email me immediately so we can try to sort that out. That being said, don't do the midterm Sunday at 8 p.m. And expect me to get back to you if you have a problem, okay? I'm leaving it on all of you to be responsible, do the midterm well in advance, and then that way if issues do pop up, we can tackle it as opposed to the deadline has come and gone and there's no midterm because there were technical issues. With that said, if you have any questions about the midterm that I did not answer, please feel free to send a message through Canvas. If I get similar questions, I will just put out an announcement so that everyone can get the answer and I don't have to respond to 3 or 5 different messages. With that, let's dive into course content for this week.
All right, so we're going to start with understanding the process. So by understanding the process, what it means is anytime there's an output or a product that's created, it has to go through a process to get to that point. The process of that product or outcome being created is going to contain opportunities for quality improvement. We're going to look at a little bit of how that process is undertaken, and then we're going to look at kind of the opportunities for change associated with that. So first of all, what is a process? So a process is a collection of interrelated work tasks initiated in response to an event that achieves a specific result for the customer of the process. Okay, so one thing just to keep in mind here as well, being healthcare, health service oriented, we have to keep in mind that the customer isn't always the patient. The customer can also be a stakeholder such as a surgeon, a doctor, a nurse, healthcare workers, basically anyone who is receiving that product or that outcome, okay? So not to say it doesn't include the patient, because the patient is definitely a customer in some of the processes that we might deal with, but we have to keep in mind everyone involved and who's receiving the outcome or the product. Now with the process, this is one example of a very simplified kind of process pathway, okay? So you have the input, which you're going to feed into the process, right? Whatever it is that's doing the work, and then it's going to spit out an output, so the outcome or the product, okay? Now, this typically depends on the input which gets transformed throughout the process. Okay, so depending what I'm being given is going to change how I go about getting my output from it, right? It sounds kind of vague and hard to conceptualize, but if you think about it, if my input is a financial input from stakeholders, my process is going to be different in producing a specific outcome as opposed to if I get material goods or if I have personnel input, right? And what I mean by that is I'm given staff, okay? So the process is always dependent on what you have available, which is the input. Now we can expand this a little bit further. What you'll notice is that simplified pathway is still the core here, but all we've done is we've added a preceding step and a subsequent step. So we always start with a supplier. So our inputs don't come out of thin air. It's always given to us by somewhere, right? Now, again, we can look at it as in a stakeholder is giving us financial support to put into the process and then create a specific output. Or it can be something like a nursing agency who's going to supply us with personnel in which we're going to put through and the outcome is going to be a service. It doesn't have to necessarily be what we would think of as a material input, okay? So the supplier is going to provide the input to us. Then that input is going to go through the process. It's going to spit out an output, so whether that is a good or a service, and then the customer is going to receive that output, okay? So once again, this is just that, it's a simplified process, just expanded a little bit in terms of our starting and our ending point. Now, typically, unless you're involved in program design, you're given the process, you are given these steps, and where we come in as kind of the quality improvement management or the quality improvement team is we look at it from kind of an external perspective, and we're going to see what we can change within that process, okay? We can either change the whole thing because it's not efficient in its entirety, or we can change individual components of that process to produce superior outcomes or outputs. Now, before we can make any sort of change, we have to evaluate kind of what we're thinking about, right? So what I mean by that is we have to evaluate two states, okay, or two time frames. The first is we have to evaluate the current state. So what is currently going on within the process and within the environment that this process is occurring in, okay? So again, if I'm going to try and use the example of like a surgical suite, right? Let's say we're focusing on something like a knee or a hip replacement, right? We're going to look at the process that this is being undertaken, but we're also going to look at the environment. So this might be the actual like standard operating procedures, the SOPs of the surgery itself. Is there a way that we can do that smoother, and is it generating the best outcome? But we can also look at the environment that it's occurring in, right? So that surgical theater itself, the personnel that are undertaking it, are there conflicting personalities that are going on within the workplace that is negatively affecting the process, so on and so forth, okay? So that's the current state. We also have to evaluate the future state. And basically what the future state is saying is just, what is it that we are tangibly trying to achieve by implementing the change, okay? So if we evaluate the current state and we understand that there may be personnel conflicts, right? There's confrontation within the operating theater. The future state might be an operating theater that is void of any sort of drama or politics, right? Now, keep in mind that sometimes this is wishful thinking, but it's the future state. It's basically what we're aiming to achieve, okay? So in the process of evaluating the future state of where we want to go, we're going to ask ourselves a few questions, okay? Now, the first thing we're going to do is we're going to ask ourselves, why is change needed now? What's the underlying reason why we're looking at this process and deciding that now is the time to change it. This is good because what it's going to do is it's going to help you potentially identify issues that are ongoing, but it's also going to make you think in terms of your priorities, right? Because oftentimes when you're brought into whether it's a unit or a facility, there's combating priorities, right? You're not just there for necessarily one thing, you're looking at everything as a whole, okay? So if we ask ourselves why is change needed now and we're working with that surgical suite example, maybe it's because we find that there's a backlog of surgeries that need to take place and we need to look at all the different surgical procedures to understand and change if there's inefficiencies in terms of time, right? Maybe that knee operation that's ongoing, maybe it's not very efficient, maybe it's taking more time than it should, and so change is needed so that we can tackle that backlog, right? Then we're going to ask our second question, which is what will happen if we do not change? Now this is relatively easy to answer because you already know the outcomes, right? This is what the current state is showing you, okay? And this really gets at, okay, if I don't change anything, is it going to continue to negatively affect kind of the circumstance, the environment, right? And you're going to look at this at kind of a bigger picture in terms of maybe if it's personnel issues that are ongoing in that surgical suite and you ask yourself what will happen if we do not change. Well, if you don't change, you're going to have continual kind of tension within the surgical suite. You run that risk of losing employees, right? This does happen in the workplace, and so you can see that there's a negative effect that hasn't yet occurred, but it may occur if you don't enact change. Now, one thing to note, while it says ask yourself, and while you may be in kind of a leadership role, most likely you're going to have a team that you're working with. If you think back to a couple lectures ago, we talked about the need for an interdisciplinary quality improvement team or performance improvement team. And you may not have consensus in regard to the answers to some of these questions, right? So you might think change is needed now because, in your opinion, that knee operation is probably one of the lengthier ones there. Whereas you might have a surgeon who is telling you, no, it might not be the knee operation that changes. Maybe we should be looking at the hip, or, you know what, change isn't needed now. You might also have conflicting answers in terms of what will happen if we do not change. Some people may think that staff will just put the tensions aside, put the confrontation aside, and keep working because that's their job. And you have those different opinions because that's what those people would do, right? So you also have to be aware that those in management sometimes will be satisfied with the status quo and they'll see no need for change, okay? So that's kind of branching onto a different discussion, but you also have to have staff buy-in when you try to enact any form of change. And that can be relatively difficult because staff typically like the status quo. They like what's known, they don't like what's unknown. Okay, so a couple things to keep in mind as you ask yourself these questions. Now, this should always be a red flag for you whenever you're working within a team or within a facility. Be aware of those in authority who resist change to stick with tradition. This is problematic because it doesn't matter what kind of data you show, it doesn't matter what kind of proof of concept you show, they will stick with the old kind of this is how it's always done attitude, okay? If you want to kind of get a look at how real this can be, take a look at kind of the work environment now, just glance through the news and look at the differing opinions in regard to the return to office kind of sentiment that's going on right now, right? You can see kind of the old school managers who maybe not so much now, but in the midst of the pandemic, we're trying to force their employees back with the idea that they're not working as well. Whereas the employees and even their managers, right? I should say their lower tier managers are saying, look, we have proof that we work better from home. We work better with a hybrid model. But despite the metrics of improved efficiency, there are those in authority. And so a good example of this as well is someone like Elon Musk, who forces his workforce back into the building despite shown efficiency and shown competency. And they bring them back into the workforce simply because that's the way it's always done, Okay, they can't conceptualize the fact that there is a better way to do things sometimes. So again, just keep that in mind. Be wary of it. Each one of those authority figures is different. So there's unfortunately no one size fits all approach to dealing with it. Now, in order to successfully evaluate a process so that you can implement some form of change, you have to identify and address some key points, some key issues in order for your vision to be formulated, right? To know kind of how to tackle things. The first of these are identifying key stakeholders, okay? So you want to know who's involved in the process. You want to know who's influential in the process, okay? You want to see who's participating and who is basically hands-on with it, and whose support is going to be critical for success, okay? Now, when I was working in long-term care, I could have, depending on kind of the area I was trying to tackle, I could have all the support of the PSWs, but if I didn't have the support of management, who was also involved in the process, my changes weren't going to be enacted. Now, vice versa, in different areas of the home, if I had management's support, but I didn't have PSW or nursing support, same thing. I wasn't going to have a very successful time trying to implement change. Okay, so we have to identify who's important and who's going to be essential for not only just implementing the change, but ensuring that that change is lasting. Okay. The next thing is deliverables. Okay, so what change will be required on delivered products? What are you producing and how is that going to change? Right? Will these products be clear and achievable? Right? So especially in the field of public health, typically you have deliverables, you have reports, you have dashboards that you have to produce in terms of a process. Okay, so you can even look at, in terms of public health, there's a dashboard by Johns Hopkins University, and they're about to take that down. Now, whenever you change the process with anything to do with COVID data, the Johns Hopkins dashboard is one of those deliverables that may see effects of that change, right? So a good example of this is, I believe it was last year we started to, in Canada, change how we were doing our testing, right? As we kind of pulled back with testing, we're not going to have an adequate kind of finger on the pulse in how much COVID is circulating within the population. Now, when you look at the Johns Hopkins dashboard, what you actually will see is from 2020 to 2021 going into 2022, you see very good data that gives you a clear picture of the trends. Now you can almost see the point where that changes and the testing was reduced and they made changes to the process, right? Instead of everyone getting tested for COVID through PCR, it started to become more rapid test dependent. And so you see those numbers start to become erratic, right? Changes had an effect on that deliverable. And now in that case, there wasn't really anything Johns Hopkins University could really do with it. However, in other circumstances, you're going to have to make changes to your deliverables. Okay, so you have to also keep that in mind when you're evaluating the process. The next is the execution of strategy. So you want to ensure that the strategy is consistent, focused, competitive, and viable. Okay, so if your strategy is not consistent, if it's inconsistent and staff really doesn't know what's going on, you're not going to have lasting change. As well as if it's focused, if it's all over the map, again, you're not going to get that buy-in that you need. The competitive nature of it just ensures that that strategy makes sense, right? It makes something more efficient. And in terms of viability, well, if you propose something that really can't be done, whether it's because of lack of resources or it's a ridiculous ask of the staff, I hope it's self-explanatory that it's not going to be enacted. Now, the last thing you have to think about is the morale of the team. Okay, so will the morale of the workforce truly improve upon implementation? You can also ask, is the current state of morale at a high enough level in which I can enact change and it be successful? Okay, So if you think, again, we're going to go back to the COVID-19 pandemic. If you think that implementing change to any sort of process that a nurse had to deal with during the pandemic after all the change they went through was a good idea, you were probably in for a rude surprise. The morale of the workforce at certain times in the pandemic was not high enough where you could start to change processes and think that it would work, right? On the flip side, if you were making a change that would improve the morale, like what this question is asking, will the morale of the workforce truly improve upon implementation? That's a different story. You might have some buy-in, right? So there's two sides of this coin that you have to keep in mind, right? Because staff are typically resistant to change, you need a high morale to implement that change, unless the change itself is going to be very beneficial and obviously beneficial to those staff. Now, there are various tools for process evaluation. We're not going to go through very many of these. I would refer you to the textbook to go through a few just to be familiar with them, or doing a Google search to kind of see what they're about. But to avoid being kind of bogged down by going through every single one, we're going to avoid doing that. They are relatively straightforward. Okay, so you have things like Pareto charts, control charts, regression and hypotheses, cause and effect matrix, failure mode and effect analysis, and brainstorming. So some of these we've either kind of touched on a little bit in the past. Others are pretty self-explanatory, like brainstorming, but we will talk about failure mode and effect analysis. Now, there are fundamental skills required for the realm of healthcare that if you have any opportunity to further develop these skills, I would highly recommend you do so. First and foremost is leadership. As someone who is implementing the change in a facility or on a unit, you have to have leadership skills because you will be the one that is coming in and presenting something novel, right? You're leading that group into a realm that they're not familiar with, okay? Now, this is one of the skills that it does take, it's a learned skill, it does take practice. However, the best way to get that skill is to throw yourself in these situations, right? Taking up that role of leadership and trying different methods, seeing what works, seeing what doesn't. The next is facilitation skills. So you have to be able to facilitate conversations and meetings, as we kind of touched on a couple lectures ago. There's presentation and training experience. So again, this is pretty self-explanatory. You're going to have to present your changes to whether it's stakeholders or to staff. You're going to have to train staff at certain levels on the new methods or the new processes that you're going to be enacting, okay? The next is educational background. So having an undergraduate degree is the start. However, having further education is always better, right? You'll learn skills and kind of a graduate degree level that will benefit your quality improvement skills, right? Things like critical appraisal of research, critical thinking, even just the knowledge translation piece of it, result dissemination, right? How to talk to people about the results you're gathering and what the conclusions of your research are. Those are all things that are learned through graduate studies. On top of that, you have continuing education courses such as Lean and Six Sigma or quality improvement initiatives that are great to have in your back pocket for just going out into the workforce. Lastly, there's project management, right? So again, pretty self-explanatory. You have to be able to manage the project from start to finish and do so at an adequate level, okay? Like I mentioned with the leadership, these are, for the most part, except for educational background, these are all learned skills in the sense of practice makes perfect. So the best way to acquire these skills is to throw yourself in a situation where you have to depend on these skills to succeed, right? And you have to be aware that you won't always be successful. However, it's always about lessons learned, okay? And it's over time, you'll get the necessary skills that you need. All right, so now let's talk about failure mode and effect analysis, or FMEA. So it's a methodology used to evaluate a system, design, or process to identify the ways in which failures can occur. Okay? Each failure is going to be essentially categorized on the potential effect of that failure and the severity of its occurrence on the overall system in which it occurs. Okay, because not all failure is going to be catastrophic. There's going to be different levels of failure, right? If a specific product is produced with a defect, the severity of that failure is going to depend on how bad that defect is, right? Whereas if it's an outcome of a process, right, failure within a knee surgery can be pretty severe, right? What FMEA is going to do is it's going to create a review of actions, whether they're planned or they're taken, that were performed, and then minimize the probability and the effect of failure should it occur. Now, through FMEA, we have three main factors we're going to use to identify a failure. So we're going to use occurrence, which is how often that failure happens. We're going to look at severity, so basically the seriousness and the range of failure. And then we're going to look at detection, so the ease at which we can detect that failure. And we're going to use these to basically determine the probability and the effect of the failure that occurs. Furthermore, there's a couple things that we must identify and understand when we performed failure mode and effect analysis. The first one, and this one's not necessarily easy to remember all the time, but it's that not all problems are important. You have to understand that you have to prioritize the most pressing problems through the use of the FMEA. Kind of if we go back to that surgical theater example, right? A failure of maybe communication between, admin and a nurse might not be so severe because there should be charting and there should be kind of a paper trail. Failure of a surgeon, whether it's human error or process error, to not recognize which knee to cut open, and you start seeing continuous errors in the sense of it should be a right knee operation, you're seeing left knee. That's a more serious problem than the problem of the nurse and the admin not getting along and not talking, okay? Understand, and that one is a blatantly obvious kind of example, but understand that there's kind of a priority list in terms of the problems you have to tackle. The next one, and we talked about this last week, is know the customer and basically the end user. We have to understand who's at the receiving end of the process and who may be next in line in processing, okay? So not always necessarily the true customer, but if you think of it in terms of kind of like a car manufacturing factory, if I have 3 stations set up and a car goes progressively from 1, 2 to 3, in this kind of avenue, if I'm looking at the process of step 1, the customer would technically be the person in step 2 because they're receiving the product next, okay? So really important to understand that, especially in something that has multiple steps. Next is know the function. So you have to understand what it is you are attempting to change and the direction you want to change it in, okay? So again, if you don't understand it, you don't even know what needs to be changed about it, all right? So kind of the neat thing with quality improvement is it provides you the opportunity to become subjectively an expert in a lot of different areas, and that's just by the necessity of the job, okay? Next, it's be prevention oriented, okay? So we want to push for continuous improvement, and we do that by always trying to prevent things from happening, okay? There's always a probability of error, and we want to minimize that as much as possible. Okay, so next we have the systems thinking or the systems approach. So basically a system is a nucleus of elements structured to accomplish specific tasks and functions. It can vary in form, fit, and function. So it's not static, it's rather malleable. And it includes things like the equipment needed, the facilities that the process is taking place in, materials or the inputs, software, personnel who are operating within the system, and then the data that's collected for the decision making regarding anything systems based. Now in systems thinking, you have to be thinking about all these different elements that we just listed. And we also have to be thinking about all the components housed within the system. Now, all these different components and elements, they are going to interact with each other. So it's not as simple as generating a list of everything that's involved and trying to identify areas that require improvement. What we have to do is see how these things are actually interacting, okay? And not only how these things are interacting, but how different personnel are going to affect how things are interacting and how things are moving forward, right? The easiest way to do this is to immerse yourself into the system itself and see what's going on, right? When I was in long-term care, what I would do is I would actually go to the floor and I would walk around. I would be as involved as I could, obviously without having specific nursing training. Like, I can't feed residents. I at the time I couldn't even transport residents. But I could sit on the floor, I could walk with the staff as they did these things and understand what was going on within the system that I was operating within, or trying to change, I should say, okay? Now, the more aware the quality improvement team is of the system and all its components, the higher the chances of success. And this goes back to understanding what is going on within the system, right? If you don't understand the process, the functions, the personnel that are involved, and the outcomes themselves, the chances of implementing lasting change are slim to none, right? Again, it comes back to also staff buy-in. If you don't understand staff or the process, and you give them something that doesn't encourage belief in that change, it's probably not going to stick around for long, okay? So basically, the systems thinking and approach is you're looking at the environment and the process together holistically, okay, and how everything within that kind of bubble operates. Now, the next thing we're going to talk about is poka-yoke, or mistake and error proofing. So this is based on the premise that humans will make errors and that mistakes are inevitable, okay? And this is something we hear time and time again, just in daily life, really, right? We always strive for perfection, but as humans, we're always going to make mistakes. So essentially, error proofing and mistake proofing processes, what they're going to do is they're going to assist operators with performing a task, okay? So we're trying to eliminate that possibility of error and mistakes, okay? So this goes back to that example of kind of having, think about someone in a factory setting or in like an operator, if there's two buttons on a dashboard and they look almost identical, and the only thing different is kind of the words on the buttons, but the button's the same shape and the same color, the chances of a mistake or an error are relatively high, okay? An easy way to mistake or error proof it is to change something as simple as changing the shape of the button, right? Even better is if we can change the shape of the button and the color of the button, right? And then not necessarily place them right next to each other, okay? So there's different ways to think about it. Again, the goal of this method is to prevent errors, and specifically those which can cause defects in the output or outcome. So basically anything that's causing some sort of failure. Now, the difference between poka-yoke and normal inspection is the immediate implementation of corrective action. We're not going to go back and analyze data and see what's going on. We want to put in that solution as soon as possible. So as we saw with kind of that button example, what poka-yoke is looking to do is alter the environment to reduce human error, okay? So I put this quote in because I thought it should essentially sear in your brain. It's very important. In an industry where human life is at stake, 99% quality should never be good enough, okay? So think about that. In healthcare, with someone's health on the line, there's always that chance of things going very south very quickly, okay? We do not have as much margin for error as there might be in other industries. So in that sense, there is always room for quality improvement, even where it might seem like there is none. Now, in order to minimize errors, what we want to do is we want to try and remove variation between processes in order to make them predictable and consistent. Now, keep in mind that this is talking about processes. It's not talking about altering the environment. In an environment such as that operator with the different buttons, we want to make things as distinct as possible, so there's no confusion as to what each button does or what each tool does, kind of thing, right? If you think about in a surgical suite, you don't want to be handing the surgeon the wrong tool because two tools look similar, okay? Even doing something like changing the handle color will help minimize those errors. When we're looking at processes though, right, we want them to be as uniform as possible such that the human operator is not racking their mind for the different process that they need to put in place. So for example, in the surgical suite, whether you're getting a knee replacement, a hip replacement, or getting a biopsy done, everything leading up until the moment you're on the table is going to be pretty similar, right? And that's because we're going to keep it uniform up until the point where we can't anymore, because that helps the nurses go, okay, I know the first 20 minutes of when I see this patient, I know exactly what I need to do, right? Instead of getting a patient and every time they get a patient, everything is different, okay? Okay, so we have two approaches in terms of poka-yoke where we can spend our energy on. We have prevention and detection. So prevention is stopping errors before occurring and preventing defects or failure. Okay, so this is the prime number one goal when we're talking about any sort of quality improvement initiative, right? We don't want errors to occur. We also have detection, which is basically identifying the defect or the error to implement corrective actions as soon as possible to eliminate the shortcomings and prevent further damage. So basically having something in place or improving the process in such a way that as soon as a defect occurs, because remember, errors are going to occur no matter what with humans, we identify it as quick as we can and stop it from creating damage before it gets, I'm going to say, more severe, okay? So if one thing we can do is such as maybe if we have an organ transplant patient, it might be implementing blood testing at certain intervals so that we can understand whether that organ is going to be rejected, right? Because the body is going to mount an immune response. We may be able to detect that in the blood before symptoms start to occur. And so we can get the process underway to rectify the issue before it becomes a systemic issue within that patient. Now we must identify the distinction between error and mistake proofing. So mistake proofing is reducing the cost via reducing waste and human issues from the workplace. Okay, so again, this is talking about the human side of things with mistake proofing. Error proofing is improving the design of a product or quality of worker life and safety. Okay, so error proofing is kind of changing the button, right? So that there's no mix up between the buttons. Mistake proofing is looking things at making uniform the intake process before the surgical procedure, right? We're eliminating the possibility of a human making an error, or a mistake, I should say. Now, we must decide on trade-offs regarding quality, price, and delivery. These things are all interchangeable, and whenever we're trying to implement any sort of change, regardless of the method we're trying to use, we have to decide on the trade-offs. We can't have everything all at once, right? So we have to understand which ones are priority at which time. Now, on top of all these methods and ways to identify issues within a process, we have to understand why things go wrong. And there's 4 reasons mainly that things go wrong. The first is time. So simply not having enough time to complete all the tasks. We only have so much time in a day, and I'm sure everyone can understand and relate to when you have more tasks than time available, right? When that happens, you're either not going to complete tasks or you're going to take shortcuts to try to complete everything, all right? That's when things can go wrong. The next is minimized effort, and there's various reasons for minimized effort, whether it's morale, it can be worker health, it can be personal life issues, so on and so forth. But everyone has periods where there's a minimized effort. The next is assumptions, which end up leading to misunderstanding of expectations, right? Maybe you're unsure of a process or you're unsure of the quality that a certain product has to live up to. You may make an assumption and that assumption might be wrong, right? And that's going to lead to a mistake or to a defect or failure. The last one is bypassing. So essentially what happens is once we finish a product, and this could be in the design phase or after one cycle of kind of the quality improvement phase, we bypass any further kind of improvement phases, right? We're not evaluating the changes that we took in place. Again, there are various reasons why this occurs. It could be time, resources, contracts, so on and so forth, or it can just be straight up ego of someone thinking I've done a perfect job and I'm good to go. When we bypass these improvement phases, it leaves the possibility for an error that has gone unnoticed to essentially fester and build into a defect or a failure. Now let's talk about advanced practice quality planning, okay, APQP. APQP creates a quality plan with customer requirements in mind that results in a process, product, or service. Now, it offers both the customer and supplier with a systematic approach to quality planning in regards to prevention and continuous improvement. So again, we see kind of those catchphrases of prevention. So we want to get ahead of the failures and the cause of the defects that are going on with whatever process, product, or service we're focused on, but also that continuous improvement. Right? So remember the quote, 99% isn't enough. We should always be striving for 100%. Now, this is not exclusive to APQP, but when we get to the planning portion, planning must always begin as soon as possible. You don't want that one to be kind of delayed in the process because that will set you back quite a bit. Now, the key is when to use APQP. So the idea is that you're going to use it during the development of new processes, services, and products. Also before any specific changes to products or processes occurs. Right? Remember, we're trying to implement our planning phase as soon as possible. It's going to be implemented in reaction to reported quality concerns. Again, so the idea here is as soon as those quality concerns are reported, as soon as it starts to trickle in, you're already in the planning phase, even as more quality concerns come in. You're going to conduct APQP before any transfer of equipment. You're also going to use it prior to process or product changes with implications on safety or compliance with standards and regulations. So basically the core kind of theme among these is any time that there's a change that's going to be enacted, right? We want to start planning as soon as we can with foresight on the change in mind that we're aiming for. Now, for APQP to work, there are a few requirements. Now, these requirements shouldn't come as a surprise to anyone. They're pretty standard when it comes to any sort of quality planning. The first is that all activities are based on the 4 W's. So who, what, where, and when. Next, activities need to be tracked via shared information. So the how and the why. Okay, so there should be a connection being made here in the sense of that sounds a lot like having to understand what's going on. Remember, at the kind of the base level of everything to do with quality, you have to understand what it is you're looking at, how it works, who's using it, and when it's being used and why. Furthermore, there's required focus on the goal of quality, cost, or delivery. Okay, so remember kind of the prioritization aspect of things. We need to really zone in on what the goals are. Okay, if we don't focus on our goals, if we don't distinguish exactly what it is we're focusing on, we can easily get distracted. So we want to know which aspect on quality, cost, or delivery that we're looking at to really zone in on the planning. Okay, so we're going to shift focus again and talk a little bit about measurements and monitoring. Okay, specifically this one principle of what a measure needs to be able to do, to be able to adequately measure, monitor, and analyze a process, okay? So the first one is detecting variation, right? This one's pretty self-explanatory. I have to understand what the data is doing in terms of like a specific timeline, looking at it from day to day or hour by hour and seeing how things are fluctuating, right? If I can't detect fluctuation or variation in a measurement, that measurement's going to be pretty much useless to me, okay? Think of it in terms of a measurement that's going to tell me whether I'm within a certain range or not. If it's only going to give me like a pass-fail kind of output in terms of measurement, it's not really going to yield much information. So I need to be able to detect that variation. The next is identifying problem processes. Third up, I have to be able to distinguish both positive and negative outcomes. All right, so I need that full picture. I need to understand what is being done well, what is being done poorly, okay? And then in terms of the measures. And then lastly, I need to be able to evaluate effectiveness. Without understanding the effectiveness of something, I really can't gauge my quality improvement plan. Okay, so we're going to tie up part one here with project management. So the next couple slides, we're going to be referring to project management as the application of skills, knowledge, and tools used to meet and exceed the requirements of a project placed by a customer or stakeholder. And so remember, keep in mind that the customer isn't necessarily what we think of as the traditional customer in terms of trading money for service or product. The customer is basically just the last person in the chain of a process who receives that product or service, right? So it can easily be the patient or the doctor. Okay, so we have 5 components to the process of project management. The first is initiating, so essentially recognizing the need to start the project, right? Recognizing the problem or the area of interest, and that we need to develop a project to tackle this objective. The second step is planning, so identifying the objectives of what we're trying to meet, and we're outlining goals and creating that detailed plan. How are we going to do what we want to do, okay? The next is executing, so coordinating and managing the team and the resources to complete the detailed plan. So this is where, to be completely truthful, in the planning and the executing phase, these are the most extensive phases in terms of project management. Then we have controlling. So we're measuring progress and we're altering the course in the plan as necessary to ensure that objectives are being met. So if anyone can kind of recall the logic model conversation, this is pretty representative of the controlling phase, right? You have your plan, but it's not a static plan. It's not a static logic model. It's in a sense, it's a living document, right? It's going to change over time. The more information, the more feedback you get on the state of the project and how close you are to accomplishing your objectives. Lastly, the last component is closing. So formalizing the completion of the project and essentially officially closing, ending the project, okay? Now it's important to note that these processes are not discrete and they do overlap, right? So kind of how I just referred to the logic model kind of principle where the document is living, it's always changing. That would sit between planning and executing and controlling, right? It goes back and forth between those 3 phases. And it's circular, right? I'm going to execute something, and as problems come up, I might have to go back to my planning phase, execute again, and then dip into the controlling component to measure my progress and make those changes. Now we have 3 integrative processes in terms of project management. The first is project plan development. Okay, so we're looking at the results of other planning processes, and then what we're doing is we're collating all this information into one consistent and coherent document, right? That's going to be our plan. Then there's project plan execution, right? So we're going to complete the plan as it's detailed in the document in order to accomplish those objectives, right? And then we have overall change control, right? So we're coordinating the change across the project in this process. Okay, so that's where that quality, continuous quality improvement is going to come in. Okay, and remember again, these should all be feeding kind of within one another. Now, when we look at project management and quality and the aspects of quality, there's really two important things to understand. Okay, the first is that in order for project management and quality to intermix, you're going to need the appropriate tool set and knowledge and ability to plan for the success, right? You have to be knowledgeable in both areas. The second thing is that the organization that you're essentially you're working for, you've been contracted to, they have to be interested in the change, right? You can't force change on an organization. No different than staff buy-in. If your staff are not buying into the change, it's not going to be long-lasting, right? It not to sound cheesy, but it has to, like, the roots have to grow in order for that to be, the change to be sustained, right? And if the organization is not interested in change in any way, shape, or form, project management is probably not a suitable avenue. Okay, you're going to have to look at other methods to tackle the problems. Okay, so that's kind of the theory behind project management. Now we're going to look at the tangible 7 steps when approaching project management. Now the 7 steps are defined across a number of phases. All right, so here we have phase 1, and we have 3 of the 7 steps in phase 1. And phase 1 is defining the project. So in our first step, we're describing the project. So we're identifying and including specifications, goals, the projected time frame, and those responsible for the tasks. So you're identifying the constraints and the assumptions, and really what you're trying to do is you're trying to clarify what the goal is, right? What's the objective? What is this project trying to do? But you're trying to do it in as simple a manner as possible. You're not introducing complexity just for the sake of it's going to make it look like a smarter or more successful project, okay? Step 2, this is where you're going to appoint the planning team. So you're identifying those who can actually contribute to the success of the team, and you're looking at it from an interdisciplinary perspective. Remember, we want people with different backgrounds to provide different perspectives, right? The more perspectives we can bring to the team, the more successful it's going to be. Step 3, so it's defining the work, okay? So you're utilizing a process flow diagram or maybe a work breakdown structure, and this can identify or assist the team in defining the work that needs to be done, okay? So we're trying to figure out what is it that we need to do to accomplish our goals. Now the next phase, it contains the next 2 steps, steps 4 and 5, and in this phase we're planning the project. So in step 4, we're estimating tasks. So we're looking at our list of tasks and we're evaluating each one, and we're trying to assign a time period to that to each task. All right, we're trying to understand how long it will take each task, how easy or difficult the task will be, and who realistically needs to be on top of it. Step 5, we're calculating the schedule and the budgets. Okay, so we're using basically the metrics we determined in step 4, and we're using that to develop a reasonable schedule as well as a budget, right? We want to, as realistically as possible, we want to outline the cost and the time frame of the project, okay? This is probably where we're going to start constructing our logic models or our performance evaluation reviews. Again, remember, logic models are not static. It's going to change over time, and this is no different. Okay, so phase 3, implement the plan. It's composed of a single step, and that's step 6, starting the project. So in this, again, it's self-explanatory. This is where you're starting to kick off meetings. You're making sure that every team member is on the same page. they know exactly where we're going, and realistic expectations are shared and in place. Okay, so the team knows exactly what it needs to do, and is basically given the green light to go and implement that plan. Right, we're going to follow everything that we've laid out so far. We then have phase 4, which is tracking the progress and completing the project. Okay, so there's almost a hidden step here that's not outlined. As you can see, step 7 jumps all the way to closing the project down, but realistically there should be a step 6B there or something like that that has that tracking the progress of the project, making sure everything's on track. If there are problems that have developed, we're going to go back and fix them. We're going to change the plan. We're going to alter things accordingly. Okay. Then that's going to bring us to step 7. Once we've done kind of that intermediary hidden step a number of times, and what we're going to do is we're going to bring about the closure of the project. Okay. So we've officially finished the plan. We've accomplished our objectives, and all deliverables have been handed to the stakeholders, and everyone's happy. Okay. We're going to look at our lessons learned. We're going to review them, and we're going to take those improvements that were suggested in that quote-unquote hidden phase, and we're going to implement them. Okay, so we're going to shift focus now. We're going on to part 2 of the lecture, and we're looking at the descriptive analysis and interpretation of statistics. Okay, so a little bit of review if you took a stats course, or even a little bit of research methods. But again, important and really applicable to the world of quality. We're really interested in what the data says and what the descriptive stats can tell us about whatever it is that we're looking at, whether that's customer satisfaction, health outcomes in clientele or patients, so on and so forth. We need to be able to describe the sample, look at the data, and really know what the data is telling us in terms of descriptive stats. Now, first and foremost, anytime we're talking about stats or the collection of data, data cleaning and pre-processing is the most important step in any sort of statistical analysis that can be done. If you mess up the data cleaning and the pre-processing, you have wasted everyone's time by the end of it, because you're using a data set that is incorrect, right? You have to be able to clean the data and make sure that it's usable and correct before you start doing any sort of analysis. This is where I'm going to venture and say the bulk of your time will be spent after you've collected data, cleaning it and ensuring that it's proper, okay? It should be noted that this is also a step that should be continuously undertaken at pretty much every phase of the project. Okay, every time you collect data, every time you add something to a data set, it should be doesn't have to be entirely reprocessed, but you should have someone there for quality control and data cleaning at all times. Now, data cleaning takes place across 3 phases. You have the screening phase, the diagnostic phase, and the treatment phase. And now we'll talk about these 3 phases in a moment. First and foremost, though, you must understand that data cleaning is the essential first step to dealing with data in any form, right? And I emphasize this in the last slide. I'll emphasize it again. It is the first and most important step. In data cleaning, you're going to be identifying outliers. You're going to be identifying values outside the realm of possibility, duplicate entries, and true erroneous entries. Okay, so sometimes you're going to collect data in which people purposely will put false information, right? So just a quick example that I've dealt with personally, doing a questionnaire and asking people their levels of physical activity in the last week. There were people that put down more time than is physically possible in the span of a week, okay? I've also seen, we asked questions about sedentary behavior in the last 24 hours. People were saying that in the last 24 hours, they spent 30 hours sedentary. That's impossible, right? So data cleaning is going to help you identify entries like this and get rid of them, all right? And there are proper ways to deal with them. Now, the judgments regarding the data must be aligned with the characteristics of the data set itself, Okay, so that being said, if I ask that same question about sedentary behavior in the last 24 hours and someone says 18 hours, well, that's a possible value. Although it might be high, it's still a possible value. It's within the characteristics of the data set itself. So my judgment on whether to keep it or not, it's not based on kind of my personal values or beliefs. It's based on what's possible within the data set. Now, I mentioned this briefly before, but data cleaning is not a single iterative process. You're not going to do it just once. It is a process that requires continuous passes of the data to ensure that it is all as error-free as possible. Okay? It is no different than editing a paper. You're not going to write your paper and then submit it. You're going to write your paper, you're going to edit it. Maybe you're going to leave it alone for a couple of days. You're going to come back and edit it again, right? You want to have that multiple kind of passes through the data to make sure that everything has been caught, right? And you're going to have multiple people on your team so that they themselves can go through multiple times, right? So you're continuously doing data cleaning. Now, one other thing that you should understand is that the process of cleaning the data itself can create errors within the data set, all right? It's kind of like programming in that sense where you're going to deal with errors in one variable or in one area, and then other errors are going to pop up in another variable from kind of cleaning that the other side of the data. This does happen often in kind of multiple organizations that I've worked at. I think I've mentioned it before, but there were dedicated teams strictly to data cleaning. Okay, that's how important the role is. That's how continuous the effort must be into ensuring clean data. Okay, so now I said there was three phases to data cleaning. That first phase, screening phase, it's the systematic screening of the data. And basically what we're doing is one of the following, or more than one. So we're going to create tables that provide the descriptive stats, the means, the ranges, the standard deviations, and that's going to be able to allow us to find outliers and unexpected values. Okay, if I look at the range of data for my question on sedentary behavior, and I notice that I see that the range goes from -5 hours to 30 hours, I know I have some data that's outside the range of possibility. I'm probably going to look into that a little bit deeper. Whereas if I look at the range of that sedentary behavior and I see 0 to 24, again, while 24 may seem virtually impossible, it's technically not impossible. So I might not have the implausible data that I would have to originally correct for, okay? I'm going to look at frequency tables as well, again, to identify outliers or inconsistent and unrealistic values, okay? I can also use visuals such as graphs to manually look for outliers or to see what the data is doing, okay? And lastly, I'm going to look at cross tabulations to better understand the data and how variables interact and relate to each other. Now from the screening phase, I move to the diagnostic phase. So I may have identified erroneous data or data that requires further investigation. What I'm going to do is I'm going to diagnose it and I'm going to essentially put it in one of 4 buckets. Okay, the first one is erroneous data. So this is false or impossible values. So again, if asking someone about time spent in the day doing something and you get anything above 24 hours, this is erroneous data. Okay. The next is true extreme data. So it's data that's true, but nonetheless it's an outlier of value. Okay, so its expected range of that variable is determined a priori. What that means is before I look at the data, I'm going to determine the range that I'm going to expect from the population, right? Now, this is where things get dicey in terms of when to kind of cut off included data. I, in the past, have always kept plausible data in there because if there are outliers, they are part of a population. You're supposed to be doing random sampling. So for example, in work I've done with physical activity, we did recruit high-level athletes as part of the study, right? Now, they are by no means average when it comes to something like physical activity, so their values that they're reporting are going to be outliers. Now, does that mean that I should exclude them from analysis? No, not at all, because they're part of the data set. Now, there is also a case, just so that you're aware, to exclude them from the data set because my research or my quality program might be looking only at making recommendations for the average person, right? So in this circumstance with the athletes, we were looking at the effect of physical activity on anxiety. Now, given the fact that the high level athletes have kind of that outlier above average amount of physical activity, they're going to skew the results. There is a case to be made to exclude their data. Okay, this is up to whoever is running the data analysis, or I should say the project manager is probably the best person to say is in charge of that. And so the important thing is not necessarily whether or not you exclude it, right? Either one is accepted practice. What's important is that you report what you did with it, okay? Next, you have true normal data. So data falls within the range of expected values. Again, as you've developed before your data analysis. And the fourth type is idiopathic data. So that's not immediately identified as false or erroneous data, and there's no explanation or connection to other data, right? It ends up popping up erroneous. Now, kind of the difficulty here is that it requires both stringent and flexible criteria to evaluate and diagnose data, right? So again, something like high-level athletes and physical activity, it's tough to really diagnose what kind of data it falls into, right? You have to be understanding. It takes a lot of thought to go through it. Typically, you're going to consult experts in the field to see what the common practice is to develop kind of your expected values and ranges and what to do with it after. You have to be flexible, but again, like I said, at the end of the day, what's important is that you're reporting what you've done. Okay, lastly, in the data cleaning 3 phases is the treatment phase. So you have to make a decision on how to deal with the data, whether you're going to correct it, delete it, or leave the data unchanged. Now, me personally and professionally, erroneous data should only ever be deleted. The reason being you cannot make assumptions as to what you're correcting the data to, okay? You're only to correct data if you have been given an updated data set that has the corrections suggested, right, from the original person who submitted the data, okay? So I've worked with data sets where birthdays were off, and what I mean by that is whoever was putting in the birth dates, they mixed up what the month and the day was. And so you get, obviously, if you're born in the first 12 days of the month, people can mix up the order of month and day, right? So if you have someone born on like the 2nd of January, January 2nd, that can be mixed up to look like you were born on February 1st, okay? Now, even though those kind of errors exist, and sometimes you can assume you know how to correct the data, you can't, as much as you're sure of how to properly correct it, it's not good practice to correct data without going back to the person who submitted it, okay? You're essentially tampering with the data at that point, okay? So you can either leave it as is, or you can exclude it outright. Now, in terms of missing data, you must determine whether the data missing is going to bias the data or not, okay? So if yes, you might have to abandon particular analysis, okay? So if you're looking at a specific variable and let's say it's been distinguished that if you're missing 50% of responses for this variable, it's going to bias the data analysis, right? You're going to have to completely abandon that analysis, okay? I've seen this happen in terms of like infectious disease epidemiology when you're trying to look at symptoms and the associated outcome of the disease, the infectious disease, but not a lot of symptoms get properly reported. So oftentimes you're missing big chunks of data. Oftentimes you'll have to abandon particular analysis in regard to the association between symptoms and disease severity. Okay. Now you can use placeholders for the analysis of blank data. So you can use NA, you can assign random numbers, like you see here, 888 or 999, and that will lessen the impact of missing data on your analysis. All right, so previously we talked about data cleaning, getting rid of erroneous values or outliers. Now we're going to talk about pre-processing. So pre-processing, basically what we're looking at doing is sometimes we have to compute or create variables that provide the proper measurements of outcome of interest. So think of turning continuous data, right? So saying something like age into categorical data, right? So you could take something continuous of age, and then you can break it down kind of by like infant, childhood, adolescence, so on and so forth, right? You can do that with a variety of variables, right? Commonly we use this in outcome variables that use kind of a continuous scale. So I've seen it done in terms of like mental health outcomes. So for example, a tool called the DAS-21, which measures depression, anxiety, and stress. It is done on a continuous scale, but then you can categorize those variables, okay? And they categorize into like normal levels, moderate, severe, so on and so forth. Okay, now be aware that if you're creating new variables or coding the data in a specific way, you require something called a data dictionary. Basically, this is just a big giant legend that tells you what each variable is, what the name of each variable is, and how you computed it, okay? Now, in terms of computing and transforming variables, keep in mind you can create categorical variables from continuous numerical data. You cannot go backwards though, okay? So I can make, let's take age, okay? I can make a categorical variable based on what we outlined before, and I can say, okay, ages 18 to 64 are going to be termed adult. That's going to be the category in my categorical variable. I can't go backwards because all I'll have in terms of information is that a specific participant fell into the adult category. I have that entire range of 18 to 64 that I now need to guess in between. And remember, we don't want to create or assume values for people. So we can't go backwards between continuous and categorical variables. We can go from continuous to categorical. We cannot go from categorical to continuous. Okay, so when we talk about descriptive statistics, basically we're talking about a numerical value that describes the sample characteristics, okay? So it can refer to things like the frequency, so the number of times a value occurs within a data set. Okay, so if I'm describing my sample and I say I have 100 participants, I might say that 70 of them were male and 30 of them were female. Okay, so I'm basically reporting on the frequencies of the sex variable in my data set. Then there's cross tabulations. So cross tabs are basically a method used to compare the frequencies between at least two variables. All right. The interpretation itself involves a chi-square test, but at its base, you can think about a crosstab. So if I'm looking at my table, it's like having the rows as the provinces and territories, and then I'm looking at the gender frequencies between all the provinces and territories in terms of the columns. Okay. It's essentially just another way to show a breakdown of specific variables and how they relate to one another. Then we have rank. So rank is the position of a numerical value in a variable in relation to the other values in that data set. Okay. Typically, we report them in the concept of percentiles. Okay. So whenever you hear someone's in like the 75th percentile, that means that their value is higher in rank than that of 75% of the sample, okay? So if your IQ is in the 99th percentile, you are smarter than 99% of the population, okay? This allows you to enable comparison that is normalized across variables by using these percentiles. We then have our measures of central tendency. So I hope you've seen them before. In fact, I'm almost 100% positive you have seen them before. So basically we have our mean, our median, and our mode. So our mean, that's the typical average. The sum of values divided by the number of values. We all know how to do this. The median, which is the middle value in all the values that you've collected. And then the mode is basically the one that appears most frequently in the data set. Okay, and again, this gives you that average on where to compare everyone else, and it's a good way to try to determine outliers as well. Okay, so then we have our standard deviation. So basically the spread of data around the mean value. This is a good way that's going to help us to identify our outliers. So if you look at the diagram here, what we see is the proportion of a sample if it's normally distributed. So you have your mean value right at the 0 mark, right in the middle of all the data points. As you move out, so you have your 1 standard deviation away, right? As you move out, you're going to have about 34% of the sample on either side of the mean, okay? Then between 1 and 2 standard deviations, both in the negative and the positive, you have another 13.6% of the sample that's located there. And then as you get further out, that sample, that proportion of the sample diminishes. So as you can see, once you hit 3 standard deviations out, you have 0.1% of your sample population in those areas. Typically, these are where the outliers exist, but again, that's something that you have to determine a priori, okay? And then the last measure of distribution we'll talk about is the standard error of the mean. This is basically the spread of the sample means from repeated samples of a population. So you're going to go out and you're going to collect data with different random samples. You're going to get the means of those samples, and then you're basically going to portray them on a graph like you see here, right? That standard error of the mean is just that spread. What does that look like when you collect all the mean values from the population? In theory of random sampling, that mean value should line up pretty closely with one another. There shouldn't be a wide spread of those values. If there is, there's typically some sort of bias going on with your sampling methods.
All right, so that's the content for this week. Just a couple of housekeeping items before we call it a day. The first is assignment 1 is due by the end of this week, so February 27th at 7:59 p.m. Again, keep in mind that timing, 7:59 instead of 11:59, which does tend to trip students up every now and then. If it is submitted any later than 7:59, you do get that 10% initial penalty. And then lastly, the midterm for next week. Just remember you have all week to do it, but you only get that one attempt. If you have any questions or concerns regarding assignment 1 or the midterm, please email me as soon as you get them rather than waiting, and then we can address them as early as possible. And with that, until next time.